Welcome to The Explainer. Today, we're going to pull back the curtain on the internet itself. We're looking at the secret languages that literally build the digital world we all live in, the true architects behind every single web page you visit. Let's dive right in.
So think about it for a second. You type a web address, hit enter, and poof, a full-blown web page with headers, text, images, everything just shows up. It really feels like magic, right? But it's not. It's all code. The real question is, what kind of code is making all of this happen behind the scenes? Okay, so to get to the bottom of this, we have to get one really important thing straight. The languages that build most of what you see on the web aren't what you probably think of as programming. Nope, they belong to a whole different family of languages, known as markup languages. And this quote right here, it absolutely nails the difference. A programming language gives the computer orders. It tells it to do something like, hey, run this calculation or sort this list. But a markup language, it's all about description. It just tells a browser how to show information. It's about presentation, not commands. A markup language is basically the blueprint for a web page. It uses these little labels or tags that you wrap around your content to give it meaning. It doesn't say, do a calculation. It says, see this bit of text? That's a big, important headline. And this part over here, well, that's just a regular old paragraph. So let's meet our first architect, the one you've definitely heard of, HTML. That stands for Hypertext Markup Language. And if we're thinking of a web page as a house, you can think of HTML as the interior designer. It's not building the foundation, but it's deciding where the walls, doors, and windows go. It gives the content its basic structure. And what's super interesting is that HTML didn't just pop into existence. It's got a family tree. It actually grew out of ideas from way back in the 60s with a thing called GML. That evolved into a much bigger standard, SGML. And then, in 1991, Sir Tim Berners-Lee took those ideas and tweaked them to create HTML specifically for his brand new invention, the World Wide Web.
So when you boil it all down, HTML has one main job: to give content structure so a browser can display it. It uses these simple tags to label every piece of the document, and that's what tells your browser, hey, make this text big and bold, and put this text in a neat paragraph. Simple as that. And here is the absolute key to HTML. It uses a fixed set of tags that are predefined. A tag like H1 for a main heading is something that every single browser in the world already knows how to handle right out of the box. It's a genuine global standard.
Okay, now let's meet our second architect, and this one's a totally different beast. This is XML, or Extensible Markup Language. If HTML is the interior designer making things look right, then XML is the super meticulous data librarian. XML couldn't care less how data looks. Its only job is to describe it, store it, and move it around.
If you remember one thing about XML, let it be this. Its purpose has nothing to do with display. It's all about packing up information in a way that describes itself so it can be easily stored or shipped between totally different computer systems that might not speak the same language.
And this is the magic of XML. Unlike HTML, the tags aren't already set in stone. You, the person writing the code, get to invent your own tags to describe your data. There's no built-in tag called sender. You make it up because it clearly and meaningfully labels that piece of data, the explainer. So let's just put them head to head, because this is the core of it all. HTML uses a fixed set of tags to show information to us, to human eyeballs. XML lets you make up your own tags to describe information for computers. One is all about presentation, the other is all about portability.
You can think of it like this. Say you have some info you need to send. With XML, you put that info into a virtual box. Then you write your own custom labels on the outside of the box: sender, recipient, date, whatever you want. Now, any computer that gets that box can just read your labels and know exactly what's inside without even having to open it. That's why it's so incredibly powerful for sharing data.
All right, this brings us to our third architect, which was a really important step in the web's evolution, XHTML. That's Extensible Hypertext Markup Language.
So if HTML is the designer and XML is the librarian, then XHTML is the super demanding, perfectionist structural engineer who wants everything built to flawless specifications.
XHTML was basically an attempt to rewrite HTML, but to make it follow the much stricter rules of XML. The whole idea was to get the display power of HTML and combine it with the rigid, error-free structure of XML. The hope was to create a cleaner, more reliable language for the future of the web.
And this gets to the exact problem XHTML was trying to solve. You know how browsers are? They're incredibly forgiving. You can write messy HTML, and the browser will do its best to figure it out and show you something. XHTML, not so much. It follows XML's strict rules, so it's not forgiving at all. It demands perfection, which forces you to write much cleaner, better code. This table really shows you what that strictness looks like. In plain old HTML, you might forget to close a paragraph tag. No biggie, the browser will probably figure it out. In XHTML, nope, that's an error, that breaks the page. In HTML, you can use uppercase tags, lowercase, whatever. In XHTML, everything must be lowercase. It's all about discipline, making sure every document is perfectly structured. Okay, so we've met the whole crew, the designer, the librarian, and the super strict engineer. But why does this whole family of languages, this history, why does any of it still matter so much for the web we use every single day? Let's just quickly recap their rules with our analogies. You've got HTML, the interior designer, who structures content for you to see. Then there's XML, the data librarian, who describes data so computers can understand it. And finally, XHTML, the structural engineer, who brought in the idea of super strict rules to make everything more reliable.
And that's the whole shebang right there. This combination, displaying content, describing data, and having a set of rules, is what makes the internet actually work. It's the reason your phone, your laptop, and some server halfway across the world can all speak the same basic language to share and present information to you.
These languages literally laid the blueprint for the web as we know it. They made everything possible, from the simplest homepage to the most complex apps we use today. And it just leaves you with one final thought. With the foundation this powerful already in place, what will the next generation of architects, maybe people just like you, build on top of it?